Good afternoon, my fabulous chemistry students. Video number 8, trends number 4, metal reactivity. And this video number 10, though, Mr. Milks, is. Oh, there you go. There's your carrot for the day. Why don't you tell me that video 10 was really labeled video 8, and then I can give you a STEM book. All right, good. Here we go. On with it. Metallic properties and reactivities. How am I doing it more metallic, left and right, up and down, that kind of stuff. Do metals have the same properties? Absolutely not. Different valence electrons, different energy levels. We are going to have all sorts of different properties in our metals. So let's get on to reactivity right away. Reactivity is the ability or tendency of an element to do chemical change. We call that to react. So if I put a metal with an acid, is it going to react? Is there going to be a chemical change? Well, as far as electrons go, metals are what we call losers. They love to lose them. Remember, they're loosey-goosey with their electrons. They don't hold on to them real tight, where nonmetals tend to be bullies. They don't want to lose their electrons. What we learned is that they want to gain that 1 or that 2 to get their valence shell. So we don't compare metals to nonmetals in this case. It's just metals are not metal. So that's how, most reactive metal, francium. Right, as I go across the period, I start on the far left, that's metals. As I go farther to the right, I eventually get to non-metal. So my metal reactivity is going to decrease. My metallic character is going to decrease. And the reason is my increased nuclear charge. Again, I'm drawing in more and stronger on my valence electrons. My shielding, of course, does not increase as I go from left to right, so that's not going to be a factor. As I go down a group, my metal character increases. And if we look at the non-metals in like group 15 and 16, where that staircase is, you can see I'm going from a non-metal to a metal. So that's going to help us remember that trend as I become more metallic as I go down. The reason, of course, is shielding. That shielding reason has been prevalent in the last few videos. We should have a good understanding about what shielding means. Now, of course, nonmetals are not metallic. Our most reactive one is fluorine, and that is because it wants that electron so much more than any other of our nonmetals. As I go across the period, my reactivity is going to increase. And it's until I get to, of course, the noble gases, because they are unreactive. The kings and queens do not like to hang out with common folk like me. Of course, the reason is increased nuclear charge. As I'm going across from left to right, I do not have any shielding variation. I have the same number of energy levels. So going down a group, my reactivity is going to decrease. And this is, of course, because of shielding again. Remember, I don't want to get that electron, which would be my reaction with nonmetals. If I have this, 7 layers of coats, I really don't want to put another electron in my pocket, because it's not going to be able to feel my inner core, if you will, that's going to attract it. That shielding is going to keep everything, from happening so fast. So here we go. I have a list of things I need to be able to do now. This list is on your paper. I would, if I were you, maybe start checking off some of these things that you're good at and the things that you're not good at. Maybe go back, check that video one more time, come ask Mr. Milks a question. We now understand metallic properties and how they change as I go up, as I go down. The same practice packets now should be able to be done because we are done with our trends and our last video, 4 minutes. Bam! See you in class.